NTU World of Wisdom. Welcome to High Impact Thesis. In this podcast, we speak with researchers from various scientific fields to talk about the motivation, goal, and potential impact of their research. We also want to give you a sense of how a Ph.D. is carried out with an emphasis on the PH, the philosophical aspects involved in pursuing a Ph.D. Hello, everyone. Welcome to the High Impact Thesis podcast. In this podcast, we invite researchers from across NTU and other parts of Singapore to talk about their research in a way that the layperson can understand. They talk specifically about what they do as well as the philosophical implications of their research on a larger scale. So today we have Mahdi, who is a researcher here at NTU. So Mahdi, welcome to the HIT podcast and thank you for being with us today.
Thank you, Christopher, for the introduction. It's very good to be invited to HIT podcast and being here to talk with you guys and also talk with other colleagues in NTU and all over the world who will listen to this podcast. And I got very happy actually from the beginning. Ahmed talked with me about this idea you guys are starting. And it's a very important approach actually because we need to show our ideas to others, especially in NTU, and get to know each other more and also know what are different people working on.
Absolutely. Right. So we want this to be a casual but fruitful discussion. You're the person that knows a lot more than all of us here, so we ask you to feel very free to answer questions, specific questions that we're going to use to guide you. So we have some questions, and we want this to be simply a guide for you to explain even more, right? So feel free to share as much as you are willing to share, as much as possible, so that our audience appreciates the work that you are doing.
Sure.
So to really get started, we like to ask our guests to give us a really quick summary of what they would tell a person if they just met them and they were asked, what is your research about? What do you tell a person?
I would tell, I'm working on making robots intelligent. That's the main topic I'm working on. Okay. And in order to make a robot intelligent, in order to have some kind of level of intelligence for the robot, there are different tasks that needs to be solved. One of them is from the vision perspective, which the robot needs to get information from the scene using the visual sensors and process them to get to understand the environment. Then after this, we have another level of information which are coming from other type of sensors like the accelerometer and IMU. Which gives you some information about how much you accelerated in each second, what was your gyro information. And the other source are like GPS information. So these are the sources mainly used for solving the problem of localization, which you want to know your position in the environment. Then besides this, we have also other tasks like the planning, which the robots wants to take a plan to go from one position to another position to do a task. So these are the different types of problem I'm working on. And the main goal is making intelligent robots that can do whatever task you tell them.
So intelligence here implies trying to do what the brain does or trying to do what the eyes do, or it's a combination of...
It's combination of... It's actually tries to do what humans do.
Right.
We want to make human-like robots. So in order to make human-like robot, you need to have the perception. You need to know, for instance, in human, every cycle, you know how much you move your leg up and put down on the ground. So from that feedback, you can update somehow your position in your mind and get to know how you move. You don't avoid you can avoid colliding with different obstacles in the environment. So actually, in order to make robot intelligent, we need to model the human. Okay, we need to use the human intelligence to be able to model robot and make them intelligent.
Okay. And when you say robot, you mean it could be not in the physical the way that we outsiders visualize robots are those things moving, the physical metallic body or something like that. But I'm assuming that for you, a robot could also be not really physical, I suppose.
Yeah, actually, the robot what I'm saying is more like autonomous ground vehicles or autonomous UAVs, unmanned area vehicles.
Right.
These kind of robots, yeah.
I see.
Also, humanoid robots and such things come in.
Say that again.
Humanoid robots and such things also come in.
Okay. So it's these traditional robots that we see when we Google robots, as well as the more unfamiliar type, like a car can also be thought of as a robot. That's what you're doing, for example.
Yeah, exactly.
Nice. So if you may just summarize, what is the general motivation of your work? Why here? Why this? Why this area for you?
If I get,
or not for you specifically, but for this field.
Okay. So if I want to talk about this field overall, why people are working on this field, because this is a field that really over time it can help human to do things faster and use, for instance, drivers to do some more important tasks, some high-level tasks, and use from the human power better. So that's one main reason that people are working on robotic more and more right now. And also there are some tasks that robots might be able to do much faster, for instance in the factories. The factories that which are building the cars and such thing, and or warehouses, which is very important. And mainly is because of this, because we can save time, we can save human resources, and we can do things much safer in the future, right? Not now, maybe. And these are the main advantages of using robots in industry. And for myself, if you want to ask how I got attracted to this field, how did I start it?
Yes.
It was mainly goes back for about 8 years ago, which I was in high school. Then we started working on robotics soccer simulation, which was simulating robots which are playing soccer. Okay. So we had to make soccer player robots intelligent. So those small robots was able to see the environment. There were 11 agents in the field for each team. Then in each cycle, we were able to get some observation from the field, position of different players, and for instance the ball and such things. Still, we had to solve some localization problem and so on, and get the decision and do the action against other teams. And that was actually part of the RoboCup competitions, which is still ongoing. And maybe I can tell a bit about RoboCup. RoboCup is a federation which are working on this robotics field, and they started the RoboCup competitions on 1990. I don't know exactly, 5 or more. Then their main goal when they established was that they create a team of robots which would be able to beat the winner of World Cup 2050. That was the main goal the RoboCup competition established.
In
2050. So still few more years left, but because of COVID, not sure what will happen. Right? Everything is uncertain now.
Okay.
All right. So I would like to ask you, is this work you are doing now somehow related to your previous experience with robotics? Like, did you have any previous experience in this field, or are you coming as a new participant?
You mean PhD, right?
Yeah, before PhD.
Before PhD, I had some background in this field. I have been working on this robot soccer simulation, then some humanoid robots like the Now robot, but was not the field I was focusing in my PhD. Okay. So in my PhD, my focus got more towards the vision of the robot and getting able to extract some kind of information from them and using deep learning and AI in these tasks. And I also started to get benefit on of the how human brain works to extract some sort of information from the image. To give more information, actually, I modeled evolutionary neurogenesis, which happens in the human brain.
Which is
Which,
what is that? If you could unpack that a bit.
Yeah. Evolutionary neurogenesis is a process that happens in the brain when you are a young person. Your brain contains a set of neurons. As you get older, the number of neurons in your brain get lower, over time. But what happens here? The thing is, when you start seeing the world, you require more neurons to be able to learn things fast. But after more time, as time goes, your brain can start abstracting some information of different neurons and make some mature neurons, which contains knowledge of different neurons. So over time, different neurons' knowledge will move into a single neuron, and those previous neurons will die. So one single neuron can do a work that, for instance, 5 other neurons are doing.
You mean like a new neuron would replace the older neurons while at the same time retaining the original information or the original processing or function?
Exactly. That's the process happens in the brain. And this is a very important thing. For instance, for Alzheimer, which is one of important illnesses for old people, this evolutionary neurogenesis also affects, because if your brain not be able to create enough neurons over time and cannot be able to pass this knowledge over time to the new neurons, so you cannot memorize things very good. So your brain needs to create new neurons, compact the knowledge into the new neuron, and so the old neurons will die. They go away.
That's interesting.
Yeah, so that's was I can say my main motivation during my PhD, which was a big one actually. And I tried to model it with a deep learning framework, inside the deep learning framework, and be able to create some feature extraction techniques, which was working in real time and much faster than existing techniques. And that's the thing I believe people in academia should work on more. Looking in the human perspective, then see what happens exactly in the brain, try to model it using these deep artificial neural networks and deep learning. Because current deep learning techniques and artificial intelligence has lots of disadvantages, and still there's a long way to go. And in order to make them powerful, we need to get idea from what happens in the brain.
So when you say that you used the brain to create an artificial intelligence model or to create a model, you mean like
I didn't use the brain actually. I used the idea of what's happening in the brain. The process.
So in machine learning, is that like dropout or what exactly?
No, actually, if you want to get some technical talk, then dropout means that helps you generalize your network. So what happens is that over each training epoch, you drop one neuron from your structure, right? And train your network with the rest of the neurons, and it's random. Over iterations, one of the neurons will get off. This is called dropout. In my process, I'm trying to compact the number of neurons in each layer of the neural network. So what happens here is that I create similar to the neurogenesis process, I create 2 new neurons. Then I know, for instance, my first layer of neural network has 10 neurons. Then I use evolutionary algorithms to try and compact the knowledge of these 10 neurons into these 2 new neurons in a way that the knowledge not change and I can keep the knowledge of the first layer. That's what I did.
All right, okay.
Okay, so now we had a good introduction about your research background and research field in general. So I'd like to dive into more details, like what's the specific problem or challenge that you are trying to address with your work? Like, what are some of the applications of your research work? If you could speak to that.
Okay, in terms of applications, right?
Applications, maybe. Yeah.
Okay, actually, so my problem was part of solving the localization problem. Okay, so for instance, that evolution in neurogenesis, whatever I introduce, my main task is solving the localization problem. The localization problem has lots of applications in robotics, for instance, for robotaxis. Then if we go, for instance, inside the port, some companies right now are working on this, moving the goods and stuff and making some robots able to do that. In these categories, the robots require some sort of localization to get to know the environment and be able, for instance, to move some goods from one location to another location and avoid colliding with other cars and such things in the environment. And it's not limited to this, actually. For instance, Amazon is working on UAV now for moving parcels.
Yeah.
Then we have other companies like Continental, which is working on the UGV kind of things to move the goods again. Then we have the humanoid robots, like the Now robot, which lots of companies right now are working on it, more for education, for instance. So in those things, because they have different kind of module, the robot requires to know whether it's in library or different places to guide, for instance, blind people or such things. Also, yeah, blind people was another thing I just came in my mind. So it's not only related to robotics also. That's another thing. So these modules, which I talk about, for instance, localization and planning, another interesting area is that helping blind people who are not able to see the environment, right? So, for instance, developing some Android application which can help to see the environment, process the data, and then tell the person, okay, there is an obstacle in front of you, there is a street in front of you, you should not cross this place. Or sometimes they want to go to some specific supermarket to buy something. It can guide them to there and they can find the thing they want to buy. And right now, one startup in Europe is working on it. So these are actually different applications.
These are the applications. Okay. How about, like, what are some of the strategies that robot researchers in general use to deal with the localization problem? Like, what kind of sensors do they use? What kind of, I don't know, algorithms, or what kind of process they use for solving this problem?
Actually, first of all, about the sensor. In terms of sensor, there are huge amount of sensors. There are different types of sensors nowadays. Like we have GPS, we have LiDAR, which maybe I give in brief about each of the sensors. So GPS is information is coming from the satellites, global positioning system, which gives information about the position of the sensors in the environment. But the problem of the GPS is that it's not good or sometimes unavailable in urban areas or in indoor places. Then next we have LiDAR sensors, which are able to measure the distance from the sensors to different position in the scene. But the problem for them is that they are very expensive and the number of points they scan is too much, and processing that much of data takes a long time. So these are the main disadvantages. Then after that we have camera, and for camera actually we have two subsets. One approach is using a stereo camera, which means using, for instance, two camera aligned with each other, which helps to extract the depths of the field. We need two camera to do the triangulation and get the depth for each pixel in the field of view. Then another thing is using a single camera. But by the single camera, we cannot get the depths, right? So for
Right.
instance, if you want to know how much the robot is moved, we cannot extract it, right? Because we don't have the scale. So what people do in this is that they use IMU. The IMU has accelerometer and gyroscope, which
IMU would stand
IMU is
for.
inertial measurement unit.
Okay.
Okay, so it has accelerometer and gyroscope. Your phones already have it, the IMU. Then, and people in this area usually use IMU and monocular camera if they want to use monocular camera, because for the UAV, having a lightweight sensor is very important. You cannot put a LiDAR on the UAV. So people usually use a monocular camera with the IMU to solve the problem. These are the different types of sensors actually we have and people use. But as I said, each of them has their own disadvantage. But and also it depends on what application you want to use. For instance, if you want to use your phone to make some good application that can help, for instance, blind people, or a small application that can connect to some car or something and can guide them, you only have what monocular camera and IMU, for instance, right? Or for UAVs, because it should not be very heavy, you can only use a stereo camera or monocular camera plus IMU and GPS. Then for the AGV things, which are ground vehicles, most of the people use the LiDAR.
Okay.
And only Tesla right now is using the camera, I think.
So for the camera, my guess would be you have to use machine learning to detect the depth.
Yeah.
Or how do you?
Yeah. If you want to use single camera, right? You're mentioning. For single camera, yeah, you need to use some machine learning and deep learning and stuff to extract the depths of the field. And it's very sensitive to the type of camera you're using. If you change your camera, you need to train a deep learning module again because the focal length of the camera is changed, right? So it's very sensitive to these settings.
And I guess at night, if it's dark, then it's a little tough. LiDAR works.
Might not work. Yeah. Night it don't work. Actually, there are new type of camera called event camera, which I think is from ETH. The event camera is the kind of camera that it gets the motion.
Okay.
It don't give you RGB kind of image, color image. It just extracts the motion in the field and just give you the edges. The parts change in the environment. And this is a new type of camera. It's not very new, actually. It's got into industry recently.
And what is the advantage of this one?
It can work in night, and the frame rate is too high. Mainly, they are using it for the UAV right now. For the small UAV, for this, yeah, it's very high speed. Yeah. And also, for instance, for RGB camera, we have this motion blur problem. When you rotate the camera very fast, you cannot see anything, right? There is all blurred in the image. But these cameras, they don't have this problem. They can clearly show you the edge of the motion in the environment. This is the main advantage of this type of camera.
I see. Okay.
All right. So we would like to move on to if you could tell us a bit about how your research process generally looks like on a day-to-day basis. Like do you work with actual robots in your lab, or you mostly spend your time writing algorithms, or how does the process looks like for you?
Okay, the process could be a multiple step, I think, and we have having some loop coming back to the beginning. So the process is that first of all, we need to collect data. Okay, for each type of robot, the position of the sensor is different, so the position of the sensor will affect your output, right? There is no general solution for this. You need, for instance, to do some calibration of the sensors to know the position of different LiDARs relative to each other. So at the beginning, I was using the robots here in my lab. in NTU to collect the data and get more sense about the data and the relationship between them and what information I can use. Then after this, after collecting data, I had a problem to solve. I had to extract some scenarios and then collect some data based on the scenario. And after doing all this data collection, I had to start algorithm development. But along this algorithm development, I had to do some testing to see what are the drawbacks of my method, what are the problems of my method. So at each stage of this algorithm design, I had to go and test it on the robot and then come back again, update my algorithm, and then test it again. So that's the main process. Yeah.
So it's a mixture of both, like experimental, if you could say, experimental work and writing code and algorithms and so on.
Yeah, it's parallel somehow. Yeah, because at the same time you are writing, you need to do experiment to see how it goes, right?
So I guess your field is more like closer to embedded programming, or what would a person who is interested in robotics want to be looking into learning? Like, I want to be into this field. I want to get into this field, for example. Then what sort of general tools would they need to be thinking about if they're leaning toward this field?
Actually, embedded programming is not that necessary with the recent achievements in GPU, then the CPUs and such stuff. And also, actually, it depends on what type of application you want to work. For AGV and UAV, I mean, it's okay now. You don't need to get very deep in embedded programming and how to use embedded systems. Right now, we have these small TX2 platforms and Jetson things from NVIDIA, which UAVs are able to carry and process the data from the camera and other types of sensors. So mainly what I would suggest to a person who wants to get into the field of robotic to learn is that start learning robot operating system, ROS, which is it's not an operating system actually. It's installed under Linux and recently Windows they support now. So this is a kind of platform that lots of drivers for camera and LiDAR sensor are available for it. And it allows a good debugging procedure for robotics and allows you to make a good structure for your platform in robotics. So this is a big essential requirement when a person wants to get into this field. And there are lots of resources available online under YouTube, for instance, for ROS. Then after this, I would suggest person to learn C++. Okay. Right now, most of the people are going into Python in terms of the programming language. But Python has some disadvantages, like it's not as fast as required in robotic area. And it has some memory leak problem when learning for a long time. So I suggest people to start learning C++, because it's very important. Then aside of this, I would suggest some, depending on the sensor actually, maybe some computer vision stuff and image processing or sensor analysis, like the IMU sensor, how they want to analyze the information. These are the main things a person should start learning.
So, okay, Mahdi, now we're going to move to an area of speculation where it's not directly related to your field, but it's something that you can have thoughts on. So when or at least when I have thought about robots, I see a spectrum. There is the robot that just picks up things, picks and puts it there, like really, really simple robot that sort of just, so to say, does what a human muscle would do, okay? And then there is an advanced form of robots that I'm not sure if it exists or does not exist, but the kind that are likely to take over humanity, the kind that would think for themselves, these kinds of things. So I see this spectrum, right? There's one that just replicates muscles, one that is very advanced, very intelligent, and so on. So I would like to just hear from you, being in this field. Can you talk a little about what advances we've witnessed since, say, the first robots landed, whenever that was, to where we are now, and then in general, where are we at this point in terms of whether it is replicating the human brain or human muscle? Where are we? What is the state of the robotic industry?
Okay. So you want to know where are we in the robotics industry and
Yes,
human
are we,
industry? Basically, the industry, I can divide it. When we are talking about muscular robots, those robots who are like the arm and are able to move things, the way people solve those kinds of robots are a bit different to the way humanoid robots are working. For the arm robots, mostly it's like solving some inverse kinematic and some mathematical modeling kind of thing. So for those arm robots, we are already in a very, very high level stage right now. They are able to do lots of stuff. They are capable to move things very accurately, up to millimeter, and also less than millimeter, than nanometer maybe right now. But when we get over from those arm robots to humanoid kind of robot, the things get much more complicated. For instance, for these robotaxis, right now there are different companies working on, right? Like Uber, Tesla, and lots of other companies. For these companies, if we see now, for instance, they are saying that we have the best robotaxi right now. If you see advertisement, it's like this. We are able to deal with different environment, but there is problem. The current stage of robotaxis and any kind of these taxis which are working environment, they need information, or better to say, they need to visit the environment at least one time before doing the test there. So they are not able to do and perform in an environment that they have not seen that before. Okay, so that's the big problem they have right now, or these kind of AGVs. Then if we move from the AGVs to UAVs have problem on being able to navigate safe. For instance, if there be some kind of mirror, they will directly crash to it. Or if there is some area that there is no feature, or imagine there is some white area that everything is white, like a corridor, like graduate hall to halls, the corridors in graduate hall to. It's not possible to extract good feature to understand the location, right? So these kind of UAV and kind of robots have this kind of problem. Then if we move to the humanoid robots, in humanoid robots, the top rank one is Boston Dynamics right now. Okay, which I think everyone know about that.
Yeah.
So the Boston Dynamic one is right now is doing very well, but the problem is that they didn't release so much about what exactly they did up to now and what they do. They don't publish anything. And most of the videos, I know lots of people see lots of interesting video from them, but they are mostly static. I mean, they're pre-recorded. They are pre-recorded joint movements that the robot is only repeating.
Okay.
So if it get into real environments, they still have problem for sure. But yeah, for getting in the full intelligence of human, there is a long way to go. Okay. It's not possible up to at least next 20 years, I think, for sure.
Okay.
Because it's a very tough problem.
Yeah, for sure.
It cannot happen soon.
So I think this question really came from this book I read, The Rise of Robots, by a guy called Martin Ford. And he was talking about, robots before were replacing manual labor, like so-called blue-collar jobs, and that the new kinds of robots, or with artificial intelligence and the the new robots we're able to create, it's any job. It's the teaching jobs, it's the lawyer's job, it's the doctor's job. Like the jobs that are more mental, those two are going
Yeah.
to be replaced because of the advances in what can be thought of as a robot, but a very different kind of robot, right? It's not a physical robot, it's more like a
Yeah,
computer
it's
program.
more like a artificial intelligence, right?
Right.
It's not exactly a robot. Yeah, that one is true. I
Mm.
also say at the beginning we are moving, for instance, drivers to do some higher level tasks, right? Also later we will have some artificial intelligence to help the governments. For sure, governments will not replace with AI, right? But
Yeah.
they don't allow it. But
Maybe in the future.
No.
but it will take a long time. But the thing is, yeah, artificial intelligence would maybe for the law, then for teaching, for sure. For teaching right now, we have lots of stuff that are using AI. Then for making questions, even for answering your question right now, they are using it. AI would be everywhere for sure. And humans, our main task would be giving idea. That's what I think.
Giving the robot some ideas.
Giving robots some ideas. Think what is interesting in the environment. What I believe is that nothing is impossible in the world. Even if you want to go back in time. I don't want to talk about it right now, but nothing is impossible. Okay? It is possible to make it, but not now. Maybe after 50 years. After 100 years. Okay? But everything is possible.
Okay. So it is possible that I guess everything can be run by robots indeed, as the
Yeah,
author
everything can
explained
be
it.
run by robots.
And then we would just be hoping they don't run us over.
Yeah. But the thing is, that's actually one big topic people are working on right now. That about this ethics in robotics and how the robotics should behave in the future, how the humans are centered in it. I mean, they are trying to. There is also a topic called AI for good that we have try to make some plans, some rules that people should follow. You should not try to make some AI that starts killing humans. Okay, this is a very important topic.
And
right?
how would this be enforced in real life?
Yeah, because for example, right now for this nuclear system, there are some laws, right? All countries are not allowed to have a nuclear system or such things, but there are some good advantages, right?
Yeah.
But for AI would be also the same. I think after 10 years, 20 years, the same rule will come in. So people are not allowed to use some sort of AI. AI for this thing, AI for this thing, AI for army is not allowed. These are the things that will come up for sure.
And so in your research, you mentioned that you sometimes get inspired by the brain or how the how humans are built or how nature is built. Are there instances where you feel that we are better off? In what sense is it constraining? The fact that you know you are a human being and therefore you think that, for example, seeing visible spectrum is default, the way that you'd like to look at the world, for example, right? So when you're designing new tools, perhaps you focus on that aspect as well. Have you found in some sense that your knowledge of how nature is or how we humans are has limited how you build robots or what kinds of robots you create rather than just the positive aspect of it?
You mean limited knowledge about
how your
the
knowledge
human...
of how we are or how nature is has
for
constrained
sure.
you?
Yeah. We don't have the knowledge actually. We don't have a deep knowledge about what the brain is doing. This is a big question right now. There are lots of people working on this question. I went to Germany 2 years ago. There was a person giving a talk about the brain. They are still, for instance, studying how your brain do this. It was an interesting topic. He was working on how brain is able to understand your location. Okay, so in order to understand it, they just got able up to 2 years ago to visualize only one neuron in the mice brain to see how the location is inspired in that single neuron. then there are millions of neurons, right, in the brain. So only one neuron is examined up to 2 years ago. So there is a long way to go only to analyze the brain of the mice. So for the brain, we have this big problem. In terms of the body movement, in terms of this, we don't have problem because this is based on kinematics, and in the kinematics problem is solved a long time. Okay. So in this sense, we don't have problem. The big sense we have problem now is that how perception of the brain is working, how the brain is able to localize itself in the environment when you are in a new environment, how the information is compact in the brain, how different cells are fired. I mean, how they activate to analyze some information from your visual perception, for instance. How your brain is able to analyze sentences and such things. These are the big things that nobody knows still. They are working on. If we get able to know it, we will be able to get some sort of simulation. But I can tell you that we have only 1% knowledge, maybe. Don't have too much knowledge.
I see. Yeah, so my question was more toward the fact that we don't know a whole lot about the brain, but we're still trying to use it as a model, right? So it's something you don't really understand fully well.
Yeah, we don't.
You already rush to build a model. I'm wondering whether that might be the problem.
Yeah, it's not actually a problem. You cannot say it's a problem. For instance, AI, deep learning. Okay, it's mainly model of the brain, right? They started to model how the neurons are activating, and that time they didn't have that much knowledge, and right now they know that it's not the realistic model of the brain, and it has lots of differences because from that time to now, lots of new knowledge about the brain has published. Now they know more, and they're trying to do something new. But the thing is, at that time, this idea helped a lot. You can see lots of applications are developing now, right, with high accuracy. But they have problem. Why? Because it's not a correct model of the brain. It's just some inspiration we got from the brain to create something that can help us now. Also, the thing is, we should not wait until we get 100% knowledge about the brain. We should start developing over time, inspire. Every knowledge we get can help us, right?
Yeah, it's interesting because this is the first time for me personally to know about the adopting this idea of neurogenesis from the brain and applying it into AI and machine learning. Yeah, it's the first time I hear of it.
Yeah, interesting.
Okay. So I think I'm interested in this because I think that this idea of robots and this idea of having helpers to mankind is very fascinating, and so I think it'd be nice to understand both the implications, like how far can you go until they become better, so to say, because obviously there was a time when perhaps only humans could do math. Now you wouldn't do math in your brain as quickly as a computer can, right? Like we are pretty much nothing relative to a computer, the kind of math it does. And so will robots come to that level as well, and how far in the future we're looking? Because this seems to be a constant theme in movies and science fiction of these robots getting very intelligent and suddenly having their own agendas. And so I was wondering if you had thoughts on those aspects of what the future of mankind and robots might look like.
I can say robots will be everywhere. Right now, next to you, we'll have one robot in the next 10 years.
Okay.
Because that the things would happen. Robots right now, we have these washing robots which wash dishes and such thing. We have robots which can read book for you. Okay, some kind of this type. Then we have robots who can wash the cars, and even the car could become some sort of robot which autonomously move you to different locations, right? Then also, it's everywhere. Cleaning your house, cooking for you. You just need to lie on your bed, wait for your food, and that's all.
Yeah,
but the thing is, life would be changed a lot. Humans
Okay.
should think
Yeah.
and see what they can do in the future, because even if you look back from the time you were a child, the life is changed, right? But the people got to it. They learned how to live with the technology and how to work with it. I mean, just need the time to pass. Technology comes in. For sure, there will be lots of people against it in the future because of lots of aspects that, for instance, making people lazy, or I don't know. People will lose job for sure. There are people who will lose job. It's something 100% will happen. While people are talking about, okay, we remove this, we moving them to a higher place. But the thing is, we need to have a better education system for this. A place that they can learn better, they can get higher skill. And the thing is, okay, we tell them, for instance, programming and development is not very hot. Okay, if you know programming, you can find a good job and get to it. But in the future, if you tell all of them how to develop, then the developing part, some program development part will be full, right? We don't need that much employee. But what happens is that later we will have some sort of jobs, for instance, AI for robot job, that they can do maintenance of the robots or something like this. We need these jobs, right?
Right.
But the whole aspect of the life will change. Nobody knows what will happen, but it's 100% not with what it is now.
Okay. Thanks. I think that's it on this speculation segment.
All right. So now we would like to move on to what are your personal interests outside of your research and academic life? Like, what do you like to do in your free time, or what kind of topics or ideas that you are interested in beyond your research work?
Actually, I do photography.
Nice.
That's the main thing I love. I'm walking in the nature. But actually, Singapore weather is not okay with me. Because before coming to Singapore, I was walking a lot.
Yeah.
But in Singapore, because the humidity, I don't walk a lot. But yeah, I like walking. I like taking photos and see how the world looks like from the camera perspective. It's a bit different.
There's a difference between what the camera sees and what you see.
You can create different perspectives, right? That's what happened. Then I like to watch some documentaries about, for instance, different aspects, different things, and get more information about the world and nature. Because these are the things I think we need to get to know more.
Do you think your work is ever inspired by? No, it definitely is inspired by the world around you. But is there any specific movies or documentaries or stories that are
actually,
not, that are whether fictitious?
Yeah. Actually, that idea came to me when I was in Germany for this Heidelberg Laureate Forum. So it is a forum that these Nobel winners and such people come and talk about the ideas and such things. So as I said, one person was there who has worked on this brain stuff and some experiments. Then at that time, I got inspired. We should make use of it. There is some significant process in the brain that nobody modeled, and it's important to model it and use it. And actually, from the beginning, from not Dutch PhD, from past, I always believe that we should get to know our nature and get inspired from them to develop something good, something that can perform well. Because the world, the whole universe is well organized. Okay? And we have different types of animals, different types of, I don't know, plants. Even from the plants, we should get some idea how they grow, how they live, what happens to them over time. So all these getting idea, we can create intelligent methods, novel techniques. It's not only also about the research, also for our own life.
Any other hobbies that you'd like to highlight? Any other interests?
Mainly photography.
Okay.
Walking in nature, photography, swimming.
Uh-huh.
That's all.
And so I'm wondering, do you feel that computational methods are likely to replace photography? Because there was a time where taking a picture meant you needed to use your mind to draw then, right? You see the world and you draw with your hands.
Yeah.
Then a time came where now you didn't need any, paint. You didn't need any brushes.
But
Take a camera and you capture the world. And then now we're moving toward...
But still paint has its own importance, right? There are lots of painters, and if someone paints something beautiful by hand, everyone will try to start to clap for him, will be excited, right? So the camera is not replace the painter. The painter is a still.
Okay.
But on the other side, we have one drawback. Nobody pays to the painter now, right? Compared to the past.
For sure, yeah.
That's the main difference that we have now. Yeah. Right now we have photographers who get money after taking good photos, but not later. Right now, artificial intelligence can create photos for you.
Right.
They have this method right now.
So now the new
now artificial intelligence create photo, no one pays the photographer. Right. But still photographing will be there. Still painting will be there. Because these are some sort of hobby or interest that people go on with, and they get some good sense about them. Right? It depends how you look at it. You look at it as a job or you look at it as a hobby.
Right. Yeah, I think it's interesting to me because it's also like a robot replacing a job, right?
It's very replaced. All the images will come from the AI and such thing. There will be no photographic image in the future.
Cool. So that will be it for today. And Mahdi, we really appreciate your time with us and your information and your knowledge. We hope you enjoyed it. Okay, and
yep. Thank you very much for sharing your research experience.
Thank you for inviting me.
Thank you very much.
Keep going this process and invite more people. Let us get to know other people, research, and be inspired with them.
For sure, that's the goal, yeah.
It's a very good platform.
Appreciate that feedback.
Thank you.
All right. Thank you very much.
Thank you.
Good night.
Good night.